relations that one should remember. So what is series LCR circuit? You have inductor, capacitor, resistor, all are connected in series. So in series LCR circuit, the first thing is you can't add these voltages algebraically. We have three voltages, one across inductor, another across capacitor, third across resistor. You can't add them up algebraically. To add them up, you need vector laws. So we'll add them up using parallelogram. This is how we add voltages. This is important. After this, you should remember the relation for impedance, XL minus XC square plus R square. Impedance is the total obstruction offered by the circuit. Like you can take this as an analog of equivalent resistance or equivalent capacitance. You can take it as an analog of those terms. So this is impedance root over XL minus XC square plus R square. They can calculate current, peak value of current, which is E naught by Z. Z is the phase difference, E naught is the peak value of EMF. Then you can calculate phase difference between current and voltage, and that is this XL minus XC by R. So if this is the equation of current, then the equation of EMF is omega t plus phi. So EMF is leading current by phase difference of phi. Phi you can calculate from this equation. Then we have power factor, which is R by Z. Then we have average power, ERMS, IRMS into cos phi. So this is what we did in last lecture. Now, all these calculations were based on the simple assumption that V naught L is greater than V naught C. Or you can write this as when XL is greater than XC. Note it down, please. We did case 1. When V naught L is greater than V naught C, or XL is greater than XC. Case 2. So that was for last class. Now, what if V naught L is less than V naught C, or XL is less than XC, means XC is greater? Now let's see what would be the difference in relation. See, the only difference in relation would be instead of V naught L minus V naught C, you will write V naught C minus V naught L. So you will have these differences. Instead of XL minus XC, you will have XC minus XL. That's it. This will remain same. Instead of V naught, this XL minus XC, you will have XC minus XL. So in that case, the expression of impedance will be it's XC minus XL square plus R square. The expression of tan phi will be XC minus XL by R. Only one major change, that is, if equation of current is I naught sine omega t, now EMF will not lead, EMF will lag. I naught sine omega t minus phi. So this is the major difference. When XL is greater than XC or XC is greater than XL, this one is the major difference. When XL is greater than XC, then EMF will lead. That this thing. Current will, EMF will lead, but when XC is greater than XL, then EMF will lag. Note it down, then we will start calculations. LCR is the most important circuit.
So what was the case 1?
Case 1 was that we did in the last class. V naught L is greater than V naught C, or XL is greater than XC.
Okay, sir.
Noor, it can come like you can get circuits where XC is greater than XL. Like I can't find a particular logic to say that XL minus XC is a rare case. Like you can have any value of C which can satisfy this thing.
Okay, sir.
Abdullah, I'll start chapter number 5. Magnetism, we have left magnetism. Then we will start EM waves and then modern physics. Optics we will do at the end. Optics would be our last chapter. Noted?
Yes, sir.
Okay, now let's solve few numericals. Question number 1. So it's given that voltage across resistor, inductor, and capacitor are 2 volt, 4 volt, and let's say 5 volt. Calculate total voltage across the circuit. You need to calculate total voltage drop across the circuit. Now listen. Total voltage drop is something that total voltage drop across the circuit. So for total voltage drop, there is a very common mistake that you can do is you can just see what is given. VL is given. Okay, if it is not mentioned that which voltage is this, peak value, RMS value, average value, then what value will consider this?
RMS.
RMS. If it is not mentioned, that means always RMS. RMS value of voltage. Sorry, this is across resistor, then across inductor, VL RMS. 4 volt. Then VC RMS. 5 volt. So a very common mistake is when I asked you to calculate total voltage, you said, okay, total voltage is sum of all voltage. Huh? Sum of all. You wrote it like 2 plus 4 plus 5, 11 volt. This is wrong. This is wrong. You can't calculate it. You can't add them up algebraically. To add them up, you need vector laws. So this calculation is wrong. It's a wrong calculation. Voltages here are vectors. You can't add them up algebraically. To add them up, you need vector laws. And which vector law? This one. So use this expression and get the value of voltage. Use this expression. Like you can write your E as E RMS as root over V RMS L minus V RMS C square plus VR square. Do it now and write your answer in chat. Always remember that you can't add these voltages directly. Yes, Abdullah, you're correct. Good, Ahmed, you are right. What about the straight one line calculations, Shahzada? Amalia is correct. Fatma, Nazira. Yes, Noor is correct. Nazira is also correct. Sania. Fatma, your answer. Straightforward thing, na? Just keep on substituting the values of VL, VC, and VR.
I'm not able to send it. I don't know.
Okay, just let me check. Shahzada, you can try now. Instead of sending to host, you can send to everyone. Try to send to everyone. If Sania and Fatima, your answers. Yes, Shahzada, it's correct now. See, this is straightforward, na? Not -5, Fatma. Sania, your answer. See, how much is VL? VL is 4. How much is VC? VC is 5 square. How much is VR? It's 2 square. It should be 1 plus 4. It should be √5. Yes, Fatma. Is it clear now? Sania, is it clear now? Okay, do it. Note it down. We'll do the next numerical. Okay, now see, next numerical. This numerical is very, very lengthy. So you have a resistor of 10 ohm, capacitor of 10 microfarad, inductor of 5 millihenry are connected in series to an AC supply and this is the AC supply is 20 sine 314 T volt. Calculate first part. Inductive reactance is a very, very lengthy question. Inductive reactance, second part. Capacitative reactance, third part. Decide which one is correct. XL is greater than XC, or in this case, XC is greater than XC. Which one is correct? Fourth, RMS value of current. Fifth, not RMS value, no, not RMS value. Impedance I need. Then I need peak value of current. Peak value of current. Then I need RMS value of current. Then I need power factor. Then equation of current. Last part. Last, I need average power. P average. Do it. It's a lengthy question, but a very, very important thing.
Sir,
Yes.
so the formula for that voltage in an LCR circuit, that's like RMS or peak value?
Which one? That formula? That's valid for all.
Valid for all. Okay, sir.
So don't forget,
scroll down.
just 1 second. Don't forget to convert this in farad, micro. You have to remove micro. Similarly, this is L 5 millihenry. Don't forget to remove this milli, that's 10 raised per minus 300. Yes. That's it. You have 5 minutes for this question. See, if you can't solve this particular question, then other circuits would be very tough to solve. This is lengthy but a straightforward thing. Try to solve it and keep telling me if you have any doubt. If you need my help, tell me in any step. But please try to solve each and every part. Fatma, unit would be ohm. Huh? Inductive reactance is like resistance. Its unit would be ohm. Yes, Abdullah, you can. Please keep writing your answers. Nazira, Mariam, Sania. Keep writing all answers one by one. Okay, Fatma. Okay, Noor. Ahmed. Shahzada. At least write the answer of first part. Okay. Mariam, Nazira, you people are not solving. I'm getting answers from Ahmed, Fatma, Noor. Shazada, not even first is solvable. Shazada is not even. Nazira, you can't even solve first part. Okay, Amalia. See, for the first part, capacitive inductive reactance XL, you know inductive reactance is omega into L. Capacitive reactance is 1 by omega C. We did this in the last lecture. Okay.
So for fourth one, we'll be using ARMS, IRMS, cos phi.
Yes, ERMS, IRMS. For power factor, which one? For average power or for power factor?
No, sir, impedance.
Impedance is XL minus XC square plus R square.
Yes, sir, yes, sir, clear.
So for average power, we'll use the same equation, ERMS, IRMS, cos phi.
Yes, Abdullah, same equation, ERMS, IRMS, cos phi. Okay, Noor. XR is nothing, it's XL. Fatma, it's either XL or XC. XL and XC. Is someone right? No, I never use this XR. If someone write XR, then that means resistance only. But I never use this convention. Okay, Ahmed. Okay, now let's solve it together. See the first part of the question. We need inductive reactance. So what is inductive reactance? XL, which is equal to omega L. How much is omega? This 314 is omega. Omega is 314 radian per second. How much is L? L is 5 millihenry. So that is 5 into 10 raised power minus 300. So we'll get XL, which is omega L, 314 into 5 into 10 raised to the power minus 3 now. So 314 into 5, let's use calculator. 314 into 5. 1570. 1570. That's Excel. So now you have Excel, inductive reactance. So second part.
Sir,
Yes, Abdullah.
10 to the power minus 3 is also there, right? So 1.5.
Yeah, that's left. Yes. Yes. This much of all. Next, we need XC. The relation for XC is 1 by omega C. How much is omega? Omega is 1 by 314. How much is C? C I have written. C is 10 raised power minus 5. So we get 10 raised to the power 5 by 314. Now I need the value of 314 is 0.0032, I guess. 1 divided by 314, 0.0032, right? So it's 0.0032 into 10 raised power 5. So that comes out to be 3.2 into 10 raised to the power 2. So that is for part 2 now. Any doubt in these two parts? Fatma, Mariam, Ahmed?
No, sir.
Yes, sir. Yes, sir.
Doubt?
I got different value.
You got different value. Is there
Yes,
any
sir.
difference in yours and my calculation up to this step?
No, sir, just two difference. Like I wrote 318.47 and you wrote 3.2.
Okay, that's the same. Third one. Shahzada, I'm solving this question.
Okay, sir.
Yes, Mariam, I can see. It's happening with many of you. Like same issue, I can network issue with Sania and Nazira also. Shahzada, you two are facing connectivity issue.
No, sir, my internet got strong.
Okay. Shahzada, so I'm solving this numerical. The first part is inductive reactance, which is omega L. I'm just substituting the values. Omega is 314, L is this, and I multiply it, and this is XL. This is what we did in the last lecture also. Huh?
Yes, sir.
Similarly, XC it's 1 by omega C, so 1 by 314 omega is this. C is given as 10 raised to minus 5. This is the value of X. Next, in the third part, decide which one is correct. XL is greater than XC or XC is greater than XL. See, you have both the values. Now, XL is this, XC is this. So you have XC is greater than XL. The fourth part. The fourth part, you need impedance. Shazada, do you remember any formula for impedance?
Sorry.
Check,
I
just
don't
turn your pages. Just turn your pages in for LCR circuit. Try to find expression for impedance. See, Shazada, this is the impedance. Huh? This is impedance. XL minus XC square plus R square. So what was the formula for impedance? Just tell me.
Sir, XL minus XC.
Then square plus R square. You can substitute their values. Like XL is, I'm not calculating this, 1570. Yes.
So in this case, it should be XC minus XL, right?
Yeah, it should be XC minus XL, but it won't matter. Okay. Ideally, I should write it XC minus XL. But even if you write XL minus XC as the whole square of that thing. So
Okay, sir.
negative sign will get just XC minus XL. So XC is 3.2 into 10 raised power 2 minus XL, which is, see, 1570 into 10 raised power minus 3 means 1.57. Minus 1.57 square plus R. How much is resistance? 10 ohm. plus 10 square. So the impedance would be, see, this is 320 minus 1.57 and the whole square of this thing plus 10 square, which is 100. So if I subtract it, then it is 320 minus 1.57. So that's 318.43 square of it. So this is root over 318.43 square plus 100. So it comes out to be root over 101397.6. 101397.6 plus 100. So this much ohm is the impedance. Now if I calculate this value,
So it's near to 318 or 317.
101397.6 plus 100, 101497. Can anyone take root of it? Like the calculator I'm using is very basic, doesn't have. Can you take root of this number? I will use this number in the further calculations. 1, 10, 100, 1000, 10,000 lakh. So
I got 317.5.
31.
7.5. I approximated many values, so I don't think so it's precise.
No, it should be near about. I just need an exact value for the further calculations. Yes, it should be around 319. That I know. But what's the exact value? Okay, I'm taking it approximately to be equal
That's 318.6.
318.6. Okay, this is the impedance. Once you have impedance, then so first is done, second is done, third is done, fourth is done. You need peak value of current. Now, how to calculate peak value of current? Peak value of Amalia will tell. Amalia, do you remember any formula for peak value?
Yes, sir.
For peak value, how do you calculate peak value of current?
E naught
Yes.
by XL.
E not by?
XL.
Not XL. See, this is LCR circuit. That XL was for circuit having inductor only. For circuit having capacitor only, we have used XC. But it's circuit having impedance, like LCR circuit. So here your I naught is this E naught by Z. Okay.
Yes, sir.
That XL we use for inductor only. For capacitor, we use XC. But for LCR circuit, we use Z. So how much is E naught? Your E naught is how much is E naught? E naught is 20. How much is Z? That's 318.6 ampere. This is I naught. 20 over 318.6 ampere. After peak value of current, what you can do is part 6. You can solve part 6. So what is part 6? You need RMS value of current. RMS value of current is peak value of current divided by 2. It's 20 over 318.6 into root 2. This is the RMS value of current. After this RMS value, what you need is power factor. Fatma, what's the expression for power factor here? Fatma, which expression you will use for power factor? Shazada will tell. Shazada, what's the expression for power factor for circuit having all elements in series, LCR circuit?
So cos phi.
What is the value of cos phi? Just Noor, you're right. Shadada, just look at here. See, in LCR circuit, we have derived this thing. Now, power factor is R by Z. Okay? R by Z. See, from the calculations, R is given in the question, it's 10 ohm. And Z is this. This is Z, 318.6. R is 10 divided by Z, which is 318.6. That's cos phi. After cos phi, we have next, which is power factor is done. I need equation of current. Equation of current is I naught sine omega t. I naught sine. No, you have to decide whether it's plus phi or minus phi. Which circuit is this? This is the circuit having XC greater than XL. XC is greater than XL. Capacitive reactance is greater than inductive reactance. So when XC is greater than XL, then these are the equations. If this is the equation of current, then this is the equation of EMF. Current leads.
Omega
If-
plus
If equation of EMF is this, can you tell me the equation of current?
omega plus phi. Omega.
So the equations are same.
Omega t plus 5.
Because if you write this equation of current, then you are saying that EMF lacks current. It's equivalent in saying if this is the equation of EMF, then current will lead. You can say that EMF lags, or you can say it like current leads. So I'm writing this equation, I naught sine omega t plus phi, because EMF is given. Sine omega t plus phi. So we have all values except phi. Fatma, from where you will calculate phi? How would you calculate phi in this equation for this case? Fatma, how would you calculate phi here? See, for phi, you can use this expression, tan phi, which is XC minus XL by R. This is the expression for calculating phi. So you can write tan phi, which is XC minus XL divided by R. How much is XC? XC is 320. How much is XL? XL is 1.57 divided by R, which is 10. This will be 318.43.
4.3 divided by 10.
Divided by 10. So this 10 phi will comes out to be 31.843 now. So when you have 10 phi, you can calculate phi. Phi will comes out to be tan inverse 31.843 now. So this is the value of phi. This is how we calculate phi. So once you have phi, now this is over. Just keep on substituting the values. Nah? Like I is I naught. How much is I naught? I naught, I naught, I naught. Is this 20 by 318.6? Sine omega t is 314 t plus phi. This is your phi. Huh? Okay, so this is also done. Last, we have left with average power. We are left with average power. See, average power is easy. ERMS, IRMS, cos phi. So you can write this as, you need ERMS. You already have the value of IRMS and cos phi. You need ERMS. See how much is ERMS? It's E naught divided by root. How much is root 2 here, Noor? I mean, E naught?
So it's 20.
20. E naught is 20. See, E naught is 20. So it's 20 over root 2 volt. When you substitute these values, you can write this as P average is 20 by root 2 into IRMS, which is 20 by 318.6 into root 2. Into cos phi. See how much is cos phi? Cos phi is 10 by 318.6. This is the average power dissipated across the circuit. This is the average power. This much of what? This is it. It's a formula based thing, but to solve other circuits, all these things should be in your mind. Like all other circuits can be derived from LCR circuit only. If you know LCR, that means you know all other circuits. Okay, just note it down. Note it down. There is one more question in NCRT on the same concept. Let's solve that one also. Tell me once you have written, I'll scroll it out. It's okay. So this question is given in NCRT. Okay, just do it first. Shahzada, any doubt in this question? Amalia, Fatma?
No, sir, it's clear. Okay, this is over. Let's do one more question. This is given in NCRT. Where is the question? Okay, do it now. 7.18 of NCRT. Do this question. Important question for school exams. Do it. Do it and write your answer in chat. I'm waiting for answers.
Is this an example or a backside question?
This is backside question.
Say that 230 volt is E naught, right?
No.
No?
If nothing is mentioned, that means which value is this?
RMS.
R.
Yeah, RMS.
Yes.
Sir,
Yes.
negligible means we'll take it as 1 or 0.
Which one?
The resistance is negligible, right? So we'll take 1 or 0.
Resistance is negligible. Take it to be 0.
0.
Resistance is negligible. That means take it to be 0. I'm waiting for the answers. Shizada, are you solving it?
Yes, sir.
Just tell me if you have any doubts. If you stuck anywhere, just tell me. Yeah. If you
So this was
can't remember
first
any
one.
formula, just tell me.
So this first one, like, what formula will take?
For the first one,
Yes, sir.
for the first one, do one thing. Like first of all, calculate the impedance. Fine. First, calculate impedance. Impedance is root over XL minus XC square plus R square. Fine. For XL, refer the first part of the previous question.
Omega.
Omega. Similarly, for XC, refer the second part of the previous question. And R is given to be 0. So once you have got Z, try to calculate IRMS, which is ERMS by Z. Okay. This is ERMS. Huh? This is ERMS. Once you get ERMS divided by Z, you have IRMS. Current amplitude, you get the RMS value. Fine. Current amplitude means peak value. For peak value, you can use this relation that RMS value is I naught divided by. Fatma, you're not solving. Okay, note. Okay, Noor. You got I naught and IRMS both. Ahmed got I naught. Okay. Amalia, are you solving it?
So what does the second question mean?
Hmm?
What does the second question mean?
RMS value of potential drop. Voltage is, see, first three equation of the derivation. Huh? First three equations of the derivation. This is how we calculate voltage across inductor I naught into XL. You have both I naught and XL. I naught into R, I naught into XC. But here is asking about the RMS value. Then instead of I naught, use IRMS. Fatma, no, Fatma is not solving. Amalia, you're solving?
Yes, sir.
Okay. Abdullah, where are your answers?
Sir, I'm doing the calculations.
Okay, you're doing the calculations. See, this is how you learn calculations. Like you do it yourself. Good, dude. No, the numerical values I have to check, but otherwise it looks correct. Shazada, did you get the value of omega?
So my 3.1.
Omega is 314.
Yes.
See, for omega, you can proceed in this way. Omega is 2 pi nu. Nu is 50, yeah? So it will be 314. Yes, Noor, it's 0.
Sir,
Okay, Abdullah. Do the second part now, Abdullah.
sir, for the second part, like we need to calculate the potential separately, right? Like VL.
Yes. Yes. VL, which is IRMS into XL, VC, which is IRMS into XC, VR, which is IRMS into R. So you're doing the same chapter in school, huh? Or you have finished it?
No, sir, we
I
started.
finished it. Started optics.
Started optics. Okay, Amalia. Amalia, in the first part, this is the impedance na, that you have calculated.
Yes, sir.
Yeah, but in the first part, I need current amplitude and current RMS value. Okay, divide this EMF by the impedance that you have calculated. Shahzada, is it current or impedance? Yes, Shahzada. Is it current or impedance? Okay, now let's solve it together. Yes, Noor, that's correct. It would be 0. So for current, you should be having impedance. For impedance, you should have XL, which is omega L. Say frequency is 50 hertz. Then your omega is 2 pi nu. 2 into 3.14 into 50, which is 314 radian per second. So it's 314 into XL, which is, see, this is 80 millihenry. Yeah? So that's 80 into 10 raised to the power minus 3 ohm. So this is 314 into 80. 25120. So it's 25120 into 10 raised to the power minus 3. So it's 25.12 ohm. That's XC. Similarly, we can calculate XC, which is omega C. Omega is 314 and C is 60 microfarad. So that comes out to be 1 by 314 by 6. It's 10 raised power 5 over 314 into 6. So which is 1 divided by 314, 6.00050. 0.00050 into 10 raised power 5. So it comes out to be 50 ohm, almost 50 ohm is this. Now you can calculate, and your R is negligible. Yes.
So why did we do that?
Which one? What Ahmed?
And the XC value, how did we get 0.0003?
This is 1 by 314 by 6. See, 1 by 314, I get 1 divided by 314. I get 0.00318. I divided by 6, I get 0.00053.
Yes, sir.
Oh, it should be 53. So let's take it as 53. 53. Now your Z is, see, XC is greater than XL. Noor, you can see in almost all numerical XC is getting greater than XL.
Yes, sir.
XC minus XL is almost 0. So saying this is rare. Huh? Someone was saying that this one is rare. Or the other one.
So this one only is there. Our school teacher said.
Square. See, the square will cancel the root simply. Na? So this is root over 53 minus 25.1. 53 minus 25.12. 27.88. 27.88 square, and let's cancel over. So you have impedance will be 27.88 ohms. This is the impedance. After impedance, the next is I have XL, I have impedance. After impedance, I need current amplitude. So I can calculate RMS value, which is first part still not over. IRMS, which is ERMS divided by Z. ERMS is 230. Z is 27.88 ampere. Then you need I naught. See, you can write that I naught is IRMS into root 2. So I naught comes out to be 230 by 27.88 into root 2 ampere. That's I. After calculating this IRMS and I naught, next what we can do is second part. In the second part, VRMS. VRMS. IRMS into XL. IRMS is 230 by 27.88. Into XL. How much is XL? XL is this 25.4. Similarly, you can calculate RMS voltage drop across capacitor. So that is IRMS into XC. So it's 230 by 27.88 into XC. XC is 53. VRMS is 0. It's IRMS into R, that comes out to be 0 since R is 0. No resistance. Second part is over. Second part is clear, Amalia? Noor? Shahzada?
Yes, sir.
Shahzada, are you getting it now?
Yes, sir, I'm getting it.
See the third part. What is the average power transferred to the inductor? See, inductor is having phase power factor of 0. So average power transferred to the inductor is always 0. Wattless current flows in inductor. We did in the last derivation. Average power transferred to capacitor, this is also 0. Last part. What is the total average power absorbed by the circuit? So when we say total average power means ERMS into IRMS into cos phi. So you have ERMS, you have IRMS, but you need cos phi. How much is cos phi? See, cos phi is R by Z. How much is R in this equation?
0.
0.
then what should be the average power here? If cos phi is 0, if R is 0, that means cos phi is 0. It comes out to be 0. So your cos phi comes out to be 0. If your cos phi is 0, how much is average power? P average. 0 again. So average power dissipated in the circuit would be 0 again. So this is how we do this calculation. Is it clear now?
Yes, sir.
Good. Do it now. Note it down. If LCR circuit is clear, then rest of the circuits are very straightforward. Note it down, then we'll do other circuits. And tell me once you have written. Yes, Shahzada. Written?
Yes, sir.
Okay. So that was about series LCR circuit. Now see. From this series LCR circuit, you can make 3 more circuits. So there is one circuit which is known as RL circuit. RL circuit means remove this capacitor. When you remove this capacitor, you will get RL circuit. Now let's try to calculate few things. In RL circuit, you will not have V naught C in the phasor diagram. Can you guess the formula of Z for RL circuit? Mariam? We don't have capacitor in RL circuit. This is the expression of Z. Can you get the value of Z impedance for the RL circuit? Yes, Abdullah. What would be the impedance for the RL circuit?
Yes, sir.
What would be the impedance Z for the RL circuit?
R square plus XL square.
Yes, just take this XC equal to 0. When you take current, it would be E naught by Z only. In phase distance, remove this V naught C. You will have only V naught L. Remove this XC, you will have only XL by R. Rest of the things will remain same. Cos phi will remain same, P average will remain same. In the same way, you can calculate RC circuit. In RC circuit, what we will do, we'll put XL equal to 0. So the next is RL circuit. So in RL circuit, you have a resistor and you have one inductor in series. And they are connected to an AC supply. This is resistor R, inductor L. AC supply is this I naught sine. So this is current I naught. Voltage would be in same phase V naught R. But inductor, this is I naught. Voltage will lead. See, if you know LCR, that means you know RL. In LCR, just remove this capacity. The rest is RL. So I'm just writing the direct formula. For impedance, you can put XC equal to 0. You will be left with XL square plus R square. For peak value of current, you will be having the same expression E naught by Z. For tan phi, you have just XL by R. If you draw the phasor diagram, which is important, this is current I naught. This is your V naught L. And this is your V naught R. See, this is your net EMF E naught. Here also E naught is ahead of this. So EMF leads current. So if equation of current is I naught sine omega t
minus phi.
E naught sine omega t plus phi. If you're taking current as I naught sine omega t, then EMF will lead. Next. After
So can
RL,
you show the previous slides?
yes.
I got disconnected.
This is power factor. This is impedance. Just 1 second, Amina. So this is power factor. You can also calculate average power. P average is simply the product of ERMS, IRMS into cos. So if you know LCR circuit, you know all other circuits. In RL, put XC equal to 0. In the next RC circuit, put XL equal to 0. So Ahmed, see. You want me to scroll further?
IRM, from IRM. Yes. Yes, sir. Done.
John? This one?
Yes, sir. Done. Yes, sir. Done. That's it.
Okay.
Yes, sir. Done.
Okay. Just note it down. Then we'll do RC circuit, then we'll do numericals on.
Yes, sir.
Always remember this phase difference. This phase difference is very, very important. This phasor diagram. Okay, next C, RC circuit. RC circuit. So now you'll remove inductor. So you have a resistor and you have a capacitor. They are connected to an AC supply. Resistance R, capacity C, I naught sine omega. So if you want impedance, Z, which is root over XC square plus R square. If you want peak value of current, I naught, then this is simply E naught divided by Z. If you want RMS value of current, then it's simply E RMS by Z. So here, if you want to draw the phasor diagram, see, this is your current I naught, this is your voltage V naught R, and this is your V naught L. For total EMF, you will add them up. This will be your net EMF. This is your net EMF. So Noor, which one lags here? EMF or current?
EMF
By what angle?
by angle
Phi,
5.
So how can you calculate phi? So let's write first the equation. See here, EMF lags current. So if equation of current is this, I naught sine omega t, then this is the equation of EMF, E naught sine omega t minus phi. Next, you can calculate tan phi, which is perpendicular upon base. So phase difference you can write as XC by R. You can also calculate cos phi, which is R by Z. Similarly, average power, which is ERMS, IRMS cos phi. ERMS, IRMS cos phi. So once you know LCR circuit, you can make RL circuit, RC circuit, and you can even make LC circuit by putting R equal to 0. So this was done, just note it down. Don't forget the phasor diagram. Phasor diagram is very, very important.
Yes, sir.
Sure.
Yes, sir. Yes, sir. Yes, sir.
So that's the next circuit is LC circuit. So we'll continue this in the next class. So I need just 2 more lectures to finish this chapter. After this, we'll complete chapter number 5. Then we'll do EM waves. Then we will come to optics if you want. Okay.
Okay.
So let's stop
Yes,
here.
sir. Thank you, sir.
Okay.
Thank you, sir.
Allah Hafiz, sir.
Love it, sir.
Allah Hafiz.